Hello, welcome to the online edition of microeconomics. My name is Elias. This time around, we want to go through Unit 2, which will basically show us some review to mathematics. Now, it should be noted that in this unit, we're not going to go deep into mathematics, but just some of the items or ideas from mathematics that we employ in economics. So I urge you to go back to some of the notes or your high school texts if you have them, and do a review of math. So I wanted us to just remind each other of what some of these concepts are, in as much as we are trying to advance in this course. Let me quickly take you through what we are going to cover in this unit. So the first thing we'll look at is the algebra and arithmetics. Now, these basically, we're just going to get ideas, and then we're going to be using these ideas when we come to the full structure of economics. Then we'll look at the tables and graphs, and from here I urge you to pay attention on how we come up with the tables and the plotting of the graphs. So this is very important, especially that economics involves a lot of graphing and tables. Okay, so we are going to look at the straight line graph as well as the curved line graphs. Then beyond this, we will look at the linear equations, and we'll also have lines and curve shifts. So from the linear equation, we'll do a bit of a graph which is linear and show how the shifts happen. Then we're going to distinguish between shifts versus movements along a given line. And finally, we're going to look at the use of graphs in economics. So if you want to read more on this, you can go to McConnell chapter number 1 and 2 and Mankiw chapter number 1 and 2. You'll see in the appendix, you'll find somewhere where these graphs are presented. Okay, so let's begin with arithmetics and algebra. So when we are looking at arithmetics, there are a number of things that we talk about, but key is that I've picked out the integers, because in everything that we'll be dealing with, the numbers we'll be bringing into this course, most of them will be integers, and then we're going to have even decimal numbers and so on. But I've left some of those in the main slides. You can go through them and check what they are. So the set of integers I is composed of all the counting numbers, that is, numbers ranging from 1, 2, 3, and so on. 0 and the negative of each counting number are also part of the integers. So we have 0 in the middle, and then we go to the negative. If we were to present these numbers, just integers alone, on a given line, let me redraw this line. So on a given line like this one, so you will have 0 here. All numbers this side, all whole numbers this side are positive integers, and all numbers going this side are negative integers, and so on. Okay, so therefore some integers are positive, some are negative, and the integer 0 is neither positive nor negative because it has no sign. Okay, the integers that are multiples of 2 are called even integers, and those that are not multiples of 2 are said to be non-even, or simply odd integers. Now let's analyze the even integers. So with even integers, you have all integers which are multiples of 2. So you start with the 0 itself, 2, 4, 6, 8, 10, and so on, even going to the negatives. Now, quick to note here is that this 0 can drop out of the number line, but however, because 0 is natural, we've decided that we put it here to put a gap in two multiples of 2's, so that in the odds, then we remove the 0 out of the sequence. So therefore, for odd numbers, we have all numbers that are not multiples of 2. With this brief introduction to arithmetics, let's move to algebra. So basic algebra is essentially advanced arithmetics. So what you'll notice is that in algebra, we also have the integers, we also have decimals, we also have fractions, and so on. Now, the only distinguishing part is that in algebra, variables are introduced, which allows us to solve problems with equations and inequalities. If you're looking at equations, it means you will be dealing with an equal sign. For inequalities, you will be dealing with an inequality sign. Now, just on the equation here, so what you have, for example, you can have x is equal to 2. This is an equation. But if you have x is greater than 2, then you have an inequality. So, signs that are used for inequalities include, number 1, greater than, then we have less than, okay, then we have greater than or equal to. You'll be seeing these signs. You have less than or equal to, then you also have not equal to. So these signs are used to indicate that you are dealing with inequalities, and we use them a lot in economics, especially when we go to linear programming. Okay, so now with this brief introduction of arithmetics and algebra, I think now we are fit for us to look at the tables and graphs and how they are used in economics. So maybe with that, let me take you through the tables. So the concept or variables are related to one another. For instance, when the price of tomatoes reduces, people buy more tomatoes. What this means is that if you are dealing with say an equation, say t, which is tomatoes, is equal to let's say a, which is a constant, minus b and p, where we are looking at the demand for tomatoes. If the price goes up, you will notice that the demand for tomatoes will reduce, because the whole of this, if a and b are positive integers, it means that the whole of this part then will become bigger, therefore making the whole equation smaller. In the same line, if the price of tomatoes reduces, it means that the demand for tomatoes then will increase, because this part of the equation will become smaller due to the reduction in the price, and therefore the demand will go up. And it should be noted that in such an equation, we are observing an inverse relationship between the demand for tomatoes and the price for tomatoes. When price goes up, demand reduces, and when the price reduces, the demand increases. Okay. So before I go, when we come to demand, I've used the word demand here so that we keep the classic illustration simple. However, when we come to the actual demand, we will see that price does not cause an increase in demand, but rather causes a movement along the demand curve. So we will distinguish this when we come to concepts of graph shifts and movement along the curve. Okay, so one way of expressing the relationship among variables is by using tables and graphs. Now, we bring in these because all numbers, all economic concepts that we deal with, you will be required, for example, maybe to show how the demand will change over time and how the supply will respond to such changes, or what effects prices will have on the demand for other commodities. Okay, so let's start with the table. So, in the graph. So a graph is a two-dimensional representation of a set of numbers or data. What this means is that if you have any graphical, when you are to draw a graph, it has to be a two-dimensional for it to make sense, because if you draw a three-dimensional, you will have too many lines crossing each other. So in this course, we've kept it simple and assumed that we are only dealing with two goods. Okay, so let's consider two variables, x and y, which are linearly related. With this then, if the x variable is presented on the horizontal axis and the y variable on the vertical axis, then the horizontal axis is called the x-axis and the vertical axis will be called the y-axis. We've used the x and y because we are saying these are the variables that we are using. So meaning if you were looking at price and quantity, it means the horizontal, if you put p on the vertical and the q on the horizontal, then the horizontal will be called the q-axis and the vertical will be called the p-axis. But in simple mathematics, we keep it that it's x and y. Therefore, the two lines meet at the 90-degree join, which we call the origin, or simply the x or y plane. And this is the start of all the graphical illustrations that we do. So let me show you one classic drawing. So if you have the vertical axis and the horizontal axis, if you have y here and you have your x here, then origin here, it means you have the x or y plane, and everything that you'll be drawing has to come on this part of the graph. Now take note that I've drawn this simple graph L-shaped because in economics negative numbers are called economic nonsense numbers. So therefore we'll keep the illustration direct to the positive numbers. In simple mathematics or in basic mathematics, you have noted probably that this line crosses here and still the origin will remain here and still be called the x or y plane. Okay, so let's look at the tables. So a table is a tabular representation of the relationship between or among variables. Note that you can present the same data using the graph or the table. So if you are given any data, the data for the y-axis, which are supposed to go on the y-axis, must be put on the y-axis, and those data which is supposed to go on the horizontal, which is at the x-axis, should be plotted on the x-axis. So consider the data in the table below showing the relationship between x and y. So given this data, then you will notice that from the x side, you have numbers ranging from 1 all the way to 6. And from the y side, numbers are reducing in multiples of 2 from 12 all the way to 2. Which means that there is an inverse relationship between x and y. This is because as you are moving from point A to point F, the values of x are increasing, while the values of y are reducing. In other words, the more the value of x increases, the less the value of y becomes. So with this then, we have introduced the graphs and tables, and expectations are that you understand them and pay attention to every detail that has been presented, so that when you go to the second session, you will have a good understanding. So thank you very much for watching. If you have questions, send an email to muauelias@gmail.com.